Hello. In this video, we will go over several ways to deal with missing values in your data. So we will consider the following types of imputing. First, you could just impute these values with some statistic over your feature. Then you could do something more advanced. You could compute the statistics over some group by feature, and we will see in a minute what it is. Then the second way is to create an indicator column, and some other approaches is to just leave these missing values as is and use some implementations that could deal with missing values out of the box. You could also predict missing values based on other features, which is typically impractical. You could use something like KNN. So this is just basically to predict these missing values, but use a KNN. And then you could drop missing values, which is almost never an option, except probably for educational purposes, just to simplify the data. Okay, let's go over different ways. So we will use Titanic data. We will split our data into two parts, and the first approach is to impute your missing values with some statistics. And the choice of statistics is up to you. You could use mean, you could use median, you could use mode. It also depends on type of the column. So if it's a numerical column, then it's probably a wise idea to use either mean or median. If it's a categorical, then you might use a mode, so most frequent value, right? So let's see how it's done. There are like multiple ways to do it. So in case if you want to impute with mean value, you could do it manually. You also could use something called simple imputer from an scikit-learn, and which will basically do it for you. Then you could compute a statistic within a group. So for example, instead of imputing missing values of age for all of the data and like computing a mean age overall data set, what you could do, you could compute a mean value of an age within different sex groups. So for example, you could compute a mean age for women, you could compute mean age for men, and then for every man who is missing his age, you impute this age with the average overall man, and for all women who missing their age, you impute their value with a mean women age, right? And again, you could do it manually. You could probably also do it using scikit-learn, but then you need to like create a custom imputer. So this is a simple example of how to do that. And probably for more advanced imputation methods, you should go to the scikit-learn and read their manuals. But this is an example how you could do that. And this will work exactly as any transformer in a scikit-learn. Okay, so the second approach is, so this is the probably the most preferable approach, is not to impute actually the missing value. So the reason for the missing values, sometimes the fact that the value is missing could be a signal itself, right? So imagine you have patient data, and you, let's say your features are different analysis of the patients. And for some patients, you will have like analysis A, B, and C. And for patients with different diagnoses, you will not have this kind of measurements, because for that diagnosis, you are not supposed to make this analysis, right? So the fact that these measurements are missing from the patient data are itself a signal for a machine learning algorithm. So sometimes you don't want to fill them up with anything, okay? Because by filling them up, you introduce some additional possible error, right? So the way you do it, you create an indicator column. So you say you add an additional column feature, which basically is 0 if the original feature is presented and 1 if the original feature is missing. And then if you want to run, let's say, a decision tree from the scikit-learn, you will eventually need to fill the original um, column with missing values, but you could fill them up with some just anomalous value, right? So the value which is not standard for this particular feature. So for the column H, we just filled it with like negative 999, and if um, your feature is different, then you just need to select an anomalous value. So basically, decision tree could understand that this 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 values they corresponds to the case where when the data, the measurement is missing. So finally, we have like lazy approach, and the lazy approach is not to deal with missing values at all, and just use an implementations that do it out of the box. And one of the example of such implementations is a categorical boosting, cut boost boosting algorithm, and we will speak about boosting, I believe, next seminar, next lecture. So it knows how to deal with missing values just out of the box. Okay, and it it basically uses the combination of the second and the first approaches. Finally, we have a type of imputation where you train an additional model. So let's say you have an age of the person. What you could do with Titanic data, you could take other features and try to and build a regression model which will try to predict an age of the person. And sometimes this will work. So for some data sets, this will work. And but it is rarely an option. The reason it's in most real situations, it's highly impractical, and so time consuming and so on and so forth. So but sometimes it could be useful, so I want you to at least know about this kind of imputation. Actually, like the most modern models, like deep learning models used for tables, for spreadsheet data, they do use this kind of approach to pre-train them, but this is a pretty advanced stuff. Okay, so you could basically a combination of this approach and, let's say, this approach, right? The second one is to look for similar observations in your data. So if you have a row with missing age, then you drop this age and you look for other observations based on other features. Select the most similar one and impute the age, the missing age, with the values from the similar observations in your data. Again, as I already told you, typically this is impractical. And typically it doesn't yield you better results because it introduces some additional errors, possible errors. And finally, you could drop missing values. It's very easy to do with the pandas. You could either drop rows, so you could drop observations, or you could drop columns. So sometimes if your columns are like very sparse, so they contain mostly missing values, they could be just completely entirely dropped, and sometimes it's fine. But dropping rows of your tables are rarely a good option. Very rarely it's a good option. It's mostly used for like educational purposes, just to simplify the pipelines. Okay, a quick recap. So what do we have? Basically 5 or 6 ways to impute the data. Either you compute a statistics over feature, or you compute a more complex statistics over a group by feature, or you create an indicator column and just impute with anomalous value, which is a preferred method, and I highly recommend use either this approach or the next approach, which is use some advanced implementation of algorithms which knows how to deal with missing values out of the box. Because most likely someone whose work is to write the production level implementations of these algorithms, they will implement the imputations much better than you will or I will. Finally, we have some other options which are rarely a good case, rarely a good choice, but sometimes they also could work. Okay, thank you. In the next video, we will spoke about random forest in the previous video. Sorry. Okay, see you.